All right, welcome back, teachers. We're continuing our conversation of Chapter 5, Integers. This is Section 5-1, Part 2, where we're defining addition and subtraction of integers. And you'll see we're working on subtraction right now. For all integers a and b, a minus b is a unique integer, n. So picture a minus b equals n, such that a is equal to b plus n. Now, algebraically, a way to think about that, and I believe this helps me a lot, is to write down exactly what this says. So if a minus b is equal to n, and we pictured adding b to both sides of the equation, remember that's a property of equality we learned at the end of the last video, then a is equal to b plus n. Right? We know we can do that. So if a minus b equals to n, you could use the definition that a is equal to b plus some number. This is the number we don't know, which is the answer to our subtraction problem. So we have some examples here that want us to use the definition of subtraction to compute the following. So you may very well know that 3 subtract 10 is equal to negative 7. A common way to think about that is if you have $3 in your checking account and you write a $10 check, then you are $7 in the hole, right? That's not what they're wanting us to think about here. They want us to use the definition they just gave us. So that's what we're going to do. So we're going to say that 3 is equal to 10 plus n. Now, what would n have to be to make this true? Well, if you're adding a positive number, your answer is just going to be bigger than 10. So we're going to walk the other way on the number line. We're going to face the other direction, and we're going to have to go negative 7 to pull that off. And that's why we know this answer is negative 7. Ready to try this again? So here we have negative 2, using the definition, is equal to 10 plus n. Of course, we're looking for our value of n. What would we have to add to 10 to make the answer a negative 2? Again, if we add a positive integer, our answer is just going to get bigger and bigger and bigger than 10. So we're going to have to add negative. And not only that, it's going to have to be a negative value that is more negative than 10 is positive. So how about negative 12 would pull that off? So that's using the definition they have. I have the answer typed up. It says let 3 minus 10 equal to n. That means 10 plus n is equal to 3. And so n is equal to negative 7. And then for the next one, let negative 2 minus 10 equal to n. Remember from the definition. Then we could say 10 plus n is equal to negative 2. Therefore, n must equal to negative 12. Now, I'll be frankly honest with you. I think this is a nice model for subtraction, but there's an easier way to think about it, and I bet you're very comfortable with the next thing I'm about to show you. Subtraction using adding the opposite approach. And this is likely the way that you learned to subtract with integers. So subtracting an integer is the same as adding the opposite. So if you have a subtract b, you rewrite that as a plus a negative b. We often say change the signs and add. And if that sounds familiar to you, because this is the model that you used for integer subtraction. So let's do some problems where we use this integer subtraction model. Okay, so 2 minus 8, we could rewrite that as 2 plus a negative 8. We said 2 plus a negative 8. Now picture walking this number line on your classroom floor. You start at 0, and then we go to 2, and that is, we're facing to the right, going positive to 2, and then we add a negative 8, which means we walk backwards, don't turn around, we walk backwards 8. and that would give us negative 6. Or you could walk to 2, from 0 to 2, and then you turn around the other way, and then you walk 8 units towards the left because the 8 is positive, and that would also take you to negative 6. So again, drawing a number line on your floor might be extreme, but I think it's worth doing and trying both of these to see that you get to negative 6. Now here, again, we're using the add the opposite rule, so I'm going to take my subtraction problem, and I'm going to change that to addition, and I'm going to take the opposite of negative 8, and that is positive 8. And of course, this is addition of whole numbers. We know 2 plus 8 is 10, and on the number line, you just start at 0 and you go to 2. You're facing towards the right, and then you're adding 8 more, and that's going to clearly get us 10. Next problem, you have negative 12. I'm going to change the subtraction to addition, and again, change the sign of the next number. So now that is a positive 5. Now on my number line, I'm at 0. I walk backwards. I'm facing the right. I walk backwards to negative 12, and then I'm adding a positive 5. I walk forward 5, and that's going to take me to negative 7. But now while I erase, I want to talk you through the number line story here. I'm start at 0. Okay, I face to the right always when I start. I walk backwards like the cat walking backwards to negative 12. Okay, so here's 0. I'm down here at negative 12. And then because I'm subtracting, I face the left now. And I'm subtracting a negative, so I walk backwards because we're going negative, and I should end up in here. Now if we do this, this is negative 12 plus 5. That's going to be the negative 7 area. Okay, try them both with that number line that you have on the floor. And then the last one, we've got negative 12. I'm going to change subtraction to addition. That 5 is positive right now. I'm going to turn that into a negative 5. And we know when we add two negatives together, we add the absolute value of each. 12 plus 5 is 17, and you keep that common negative. Now let's look at the results that we get typed up. So as a reminder, you change your subtraction to addition, change the sign of the next number. 2 plus a negative 8 is negative 6. Next problem, again, you change subtraction to addition. That gave us 2 plus. You change the negative 8 to the opposite. Positive 8 and 2 plus 8 is 10. Next problem, change your subtraction to addition. So this subtraction turns into a plus. Negative of a negative 5 is plus 5. Negative 12 plus 5 is negative 7. And then the last result, we have negative 12 minus 5. Change subtraction to addition. But don't forget to change this positive 5 to as negative 5. Negative 12 plus a negative 5 is negative 17. Now the next problem, we should rewrite each expression without parentheses. Okay, so first, notice we have a subtraction problem. Let's handle that. So this is equivalent to negative. This is going to be b, subtraction, changes to addition, and you change the sign of the next number. So negative b plus a negative c. Now what about this negative out front? It applies to both of these values. So this is going to be negative b plus negative of a negative c. And then simplify the two opposites here. That's going to give you negative b plus c as your final result. For the next one, again, change your subtraction to addition. So this is going to be a, the subtraction turns into addition, and then I have to change the sign of the next value. Okay, so now, because this is addition, I can distribute this negative inside. So that's a plus, think about this as a negative b plus a negative c. Now that to me is okay, but you could also write that as a plus a negative really means minus. So this is A plus a negative is minus B and minus C. I'm curious to see how the typed up answer played out for that one. Okay, just to recap with the typed up version, the negative out front, remember you change your subtraction to addition, and you change the sign of the next number. Then this negative that's out front goes inside with each, and then we end up with the answer that we had, which was negative B plus C. And the next example, again, first of all, start with changing your subtraction to addition. Change the sign of the next. Now this negative goes in with both. And where does that leave us? Look, they regrouped. They wrote A plus a negative B. Okay, they regrouped here, plus a negative C. And then they wrote it all out, A plus a negative B plus a negative C. Remember, I took that extra step and wrote it as A minus B minus C. That is the same thing, but it looks like they wanted it that way. And we did write it without parentheses. So we're supposed to simplify each of the following expressions. So what can we do here? Once again, just like the last problems, how about we write this subtraction using the definition where we treat this as change subtraction to addition, and you change the sign of the following number. So notice I made that positive 5 minus x to a negative 5 minus x. Then we can distribute that negative inside, so that's 2 plus. Now this is going to be a negative 5, and then, oh, you know what? Let's back up. You know what I didn't do? I'm going to erase. There's a subtraction inside those parentheses as well. So let's do a mid step here. Again, I handled the first step actually correct, but this subtraction, let's change that to plus a negative x as well. And then when we distribute that negative inside, it's going to be plus a negative 5 plus a negative of a negative x. That's going to give me, now can I just go ahead and add 2 plus a negative 5? And I argue that we can because we do addition left to right, correct? So 2 plus a negative 5 is negative 3. And then these two opposites here turn into plus x. So we can write that as negative 3 plus x. You should also know that the commutative property of addition would allow us to write this as x plus a negative 3, which is also equivalent to x minus 3. And that almost looks a little bit better than negative 3 plus x. They are the same. Now, you want to look at their typed up version of that? Okay. So, again, they changed, reminder, changed subtraction to addition. And they also changed this subtraction to addition. That's the one that I forgot to do right off the bat. All right, then the next thing they did was take this negative inside, and that gave us this line right here. The two negatives here turned positive x. 2 plus a negative 5 is negative 3. And they did, I like that, they flipped it around and wrote it as x minus 3 also. Now, let's see what we can do with this next one. And I'm not going to forget this time. I'm going to change this subtraction to addition, change this subtraction to addition, but don't forget to change the sign of the following. So 5 plus a negative, and then x plus a negative 3. Now, scooting over, I'm going to take that negative inside. So 5 plus, it's going to make that a negative x, plus a negative of a negative 3, which is 5 plus a negative x plus 3. Now, I could use the commutative property and switch the order of these. That would be 5 plus 3, and then minus x. And then finally, we know 5 plus 3 is 8 minus x. And again, let's look at the typed version here. Let's see if they used the same logic. I'm sure they did. They changed, again, those two negatives to addition, and then of the opposite, just like we did, and then distribute that negative inside, so the negative is with each one. The two negatives opposite here with the 3 turn positive, and then they did not regroup using the commutative property of addition, but they really did. They had to. 5 plus 3 is 8, and then you have the negative x, and you could also write that as 8 minus x, which they didn't do earlier, but we did do that earlier on a problem. Sometimes it's really hard to tell how you want to write this the most simplified way. And here's an example C where we're doing the same type of thing. So what do I want to do? I want to handle my subtraction parts first. So I'm going to change that subtraction to addition and change the sign, and change that subtraction to addition and change the sign. So this negative out front, I'm not doing anything with that yet. So x plus negative y, and then here again plus a negative y. Next, I handled this set of parentheses by distributing this negative inside. So negative goes with the x, plus then a negative goes with the negative y, plus negative y. Now we have negative x plus, now this negative and this negative, or the two opposites, make a positive, plus negative y. Now think about your chips. You've got a negative, I can say this right, a positive y added to a negative y. It's like the plus and the minus cancel each other out. There's y of the pluses and y of the negatives. And that just leaves us with the result of negative x. And we're finished with that one. Now again, like always, let's look at the typed up version and see how they handled it. So very first step, again, they handled these two subtractions by changing to plus a negative and plus a negative. That was also our first step. The next thing is they handled the distribution, this negative in front. Here goes inside, and there it is, negative and then negative. Now what we know is that two negatives make a positive right here, so these two negatives here turn into plus y. They regrouped this time. Sometimes they do, sometimes they don't. So they took the negative x plus y and they grouped together these two instead. And those cancel and you get negative x, just like we got. Now let's point out some things here. Recall that subtraction is neither commutative or associative. So you cannot commute the terms in subtraction. You can't move the subtrahend to where the minuend is, or the minuend where the subtrahend is. An expression such as 3 minus 15 minus 8 is ambiguous unless we know in which order to perform the subtractions. So what we agree to do is always work left to right. So to do this problem, you would first perform the 3 minus 15. And of course you could write that as 3 plus a negative 15 and then plus a negative 8. And then we do 3 plus a negative 15 is negative 7 plus a negative 8, and that results in negative 15. Because we know the rule is when you add both negatives, you just add the numbers together or even the absolute values of the numbers to get 15, and you keep the common sign. And we have 3 more of these problems to do before we call this lecture complete. So 2 minus 5 minus 5. Now again, there are no parentheses, so we are required to perform the 2 minus 5 first. And if you think about this on your number line, remember you face to the right, you step up to 2 because 2 is positive, and then you face the other direction. You face the left because you're subtracting, and you walk 5. Now that's going to take you to negative 3. You could also imagine that you have $2 in your checking account, and you write a $5 check, and you're $3 in the hole. But what we typically do is change subtraction to addition and change the sign of the next number, which we would be required to do here as well. There we go. And then you could actually do the addition here. So anytime you're adding opposites, you actually subtract. 5 minus 2 is 3. The larger one is negative, so that's a negative 3 plus a negative 5. And then we get to use the rule that when the signs match, you add the numbers together and you keep the common sign. So negative 8 is what we got there. Now do me a favor, go ahead and pause the video and complete the other two to make sure we're on the same page. Now checking results for the first one, there is their negative 8. Notice they didn't even address how they handled it. They just did 2 subtract 5 is negative 3, and then the subtract 5 again is negative 8. All right, for the next problem, 3 minus 7 plus 3. Again, no parentheses, so we must work from left to right. Again, what's easiest, I do believe, is to change your subtraction to addition and change that sign of that. So positive 7 turns to a negative 7. Now this is plus 3. It remains plus 3. Don't change any additions to subtraction. That's not something you want to do. 3 plus a negative 7 is negative 4. What rule did I use there? When you add opposite signs, that's what we're doing, right? You subtract the two numbers. 7 minus 3 is 4. The larger of those two absolute values is 7. So, and it's negative. So that's why my answer is negative 4 plus 3. We get to do that again. I'm adding opposite signs, so I subtract 4 minus 3 is 1. But I keep the sign of the larger absolute values. 4 is larger, so it's negative. So my answer is negative. And there's that negative 1 result there. And then for the very last problem, we have parentheses. So you know what that means. We have to perform the operation in the parentheses first. So I'm going to use the rule where we change that to addition, and then we change the sign of the next number. So this is equivalent to 3 subtract, and again, 7 plus a negative 3, which is, let me write it down for you, 7 plus a negative 3. Now the rule is when you have opposite signs, and this is a positive added to a negative, is you subtract the numbers. 7 minus 3 is 4, and you keep the sign of the larger, and since the larger is 7 and it's positive, I keep that as positive 4. Well, now we have another subtraction problem. And most of you know very quickly that 3 subtract 4 is negative 1. But if we use the rules, I'm going to change my subtraction to addition, change the sign of the next number. So I'm really calculating 3 plus a negative 4. They're opposite signs, so I subtract 4 minus 3 is 1. Again, the absolute values of these numbers, the 4 is bigger than the 3, and the 4 is negative. Therefore, my answer is negative 1, which matches. And if we look up the typed version, that's exactly what they did, in less steps and less explanation. So this wraps up section 5-1, which is discussion of adding integers and subtracting integers and different models to pull that off. If you have any questions whatsoever, please let me know and have a great day.